One of the most prominent NIST speaker is next, and he is my dear colleague and friend, Dr. Ron Ross. When Ross speaks, rooms are quiet and people listen and they take notes. I've been there and I've seen that. When Ron is posting on LinkedIn, in seconds the viewers are reading and reposting. And this is because Ron, a NIST fellow, is the symbolic voice of engineering-based cybersecurity here at NIST. Please welcome our very own Dr. Ron Ross.
Well, thank you very much, Michaela, and hello to Zach out on the West Coast, and thanks for everyone for joining today. Starting out, two great presentations by Kelsey and Joe, and I'm going to take my 20 or 25 minutes today to give you an update on something I told you about last year, but we've actually made significant progress, and that's the NIST SP 800-160 series. That's our kind of our flagship engineering publication. So if you can go to the next slide, please. About a year ago, we kicked off a project to update both volumes of the 800-160 series. Volume 1, as many of you know, that's our flagship publication on security engineering. And if you were listening to everything that Kelsey and Joe were talking about today, they're all of those components that they were mentioning in the zero trust architecture and all of the SaaS connectivity and all the things that Joe was just talking about. All of those components have to be constructed by systems engineers and software engineers. And so the purpose of the 800-160 series, especially volume 1, is to talk about the design principles that engineers, whether they're software or systems engineers or computer engineers, what are the basic principles that they should be using to construct components and systems that are more trustworthy and secure? And of course, that leads into the whole discussion about cyber resiliency, which is a hot topic today as well. We also updated our volume 2, which is designing and building cyber resilient systems. But today's focus, I want to give you an update on the volume 1, revision 1. Next slide, please. One thing that continues to come up in every discussion, Michaela mentioned the OMB policy on zero trust strategy that was published yesterday. The notion of complexity is something you don't hear about a lot in the executive orders and the policies, but it underlies everything that we're going to be talking about in the world of trustworthy, secure systems. And I agree with Kelsey. When we talk about zero trust, it's kind of an unfortunate term because it is implicit zero trust, the implicit trust that we're trying to discourage. We do want to have the ability to trust components and systems, and the way we do that is applying the basic design principles that we've known about for the past 40 years, and then also making an assurance argument about why what we've done in that design and development process is not only correct, but also effective. And those are two terms you're going to hear a lot. But complexity continues to be our number one threat to everything that we care about today, whether we're talking about national security or economic security, because the flip side of complexity is attack surface. And this is one thing I hope everybody keeps in mind. We're going down the road of zero trust. Zero trust architecture is only one component of building more trustworthy, secure systems. It's an important set of architectural constructs and things we need to pay attention to, driven by identity, authorization, access control, all the things that you heard about this morning. And that technology is maturing, it's there, it's effective, but all of that has to be assembled into something that we call a system, or as Joe mentioned earlier, really it's a system of systems today that we're communicating across the globe. So we're going to talk about complexity today and how to manage and reduce that so we can get to the point where we can trust our components and our systems to a much greater degree. Next slide, please. Well, the current landscape, I call this the black box, and you heard a lot about the system stack this morning so far. Applications, middleware, operating systems, firmware, integrated circuits, and all connected on 4G going to 5G networks. But we still have very little understanding about what's inside the black box. And that lack of transparency and traceability of requirements back to the stakeholders' needs that's still a big impediment to our ability to have more trustworthy, secure systems. So we're going to talk today about how 801.60 is going to try to remedy that to some degree. And of course, what I'm going to talk about today are the updates that we did to the 160 Volume 1, but the more exciting part of the project is yet to come. That publication now is out for public review. We closed out our public comments on February 25th. I've got the URL later in the presentation. We'd love your comments on the current draft, but once we lock down this publication, we're going to then pivot and try to see how we can apply the fundamental concepts of the design principles for trustworthy, secure systems and components to the world of DevSecOps and the world of agile development. That's where all the action is today. That's where all the innovation is, the pipelines, the process that many of you are very familiar with. The question we're going to ask is, how much security is actually in the DevSecOps process? How much needs to be there? What can we take from the traditional world of trustworthy, secure systems and apply to that process so it continues to be rapid, operating at the speed of commercial industry, yet provides the level of trust that we need as consumers, especially in critical applications and critical infrastructure. Next slide, please. So one of the big problems that we still have today, and I'm thinking zero trust is going to start to help this situation a little bit, but it's not going to get us all the way to where we need to be. Into smaller resources where we can protect those individual resources to a much higher degree than we do now. But that single dimension of penetration resistance at the boundary is still a problem because we know even on our best day, because of complexity, and the adversary seems to have the ability, especially with high-end tools and very sophisticated attack methods, advanced persistent threat, 5 to 10% of the time, they are coming through that initial perimeter. And the real question is, what do we do after that? And of course, zero trust is going to provide a lot of that protection inside the perimeter. So we can slow down the lateral movement of the adversaries once they're inside. We can increase their workload. We can make their life miserable by having that segmentation, micro-segmentation, virtualization, micro-virtualization. So we're going to be churning the infrastructure faster than the adversary can take advantage of the attack. And that's that kill chain, that attack sequence. We have to be able to disrupt that as it's going on. And of course, zero trust is going to be one of our best tools to make that happen. But ultimately, the single dimension is not working. And that's where we talk increasingly about multi-dimension protection strategy, where we try to stop them at the boundary through good penetration resistance, the basic blocking and tackling of cybersecurity that we've done for decades. When that fails, we try to limit the damage the adversaries can do and ultimately get to a point where we have something we call system resilience, which means we can take a punch, continue to operate, even if that system is going in a degraded or debilitated state. Next slide, please. So the objective, the long-term objective, is to stop doing cybersecurity as a stovepipe. The best way to build more trustworthy, secure systems is to embed those basic principles in the life cycle of the system development, life cycle process. Whether you're software engineers or systems engineers, we don't want to have two different teams working. We want to be integrated as one, with those principles being carried out by systems and software engineers. If you think about the power of DevSecOps, identifying weaknesses and deficiencies by those software development teams early in the process, that means they can fix those things that if they don't fix them, they become vulnerabilities for the customers on the other end. And being able to do that in almost a near real-time setting as part of that agile DevSecOps process, that is really a game changer in industry. It can keep us innovating and moving forward, but yet making sure that the basic security that we need to trust these systems and the components, hundreds and thousands and millions of components, is there. And that's really the whole message of 801.60 is embedding security as an emergent property, just like safety is an emergent property of a systems development for an automobile or a space shuttle. we're embedding security into the lifecycle process so we can better understand what are the intended behaviors and outcomes of any system or any component. And we have to be able to do that with some degree of assurance so we can understand how much do we need to trust this particular component. And when those components are composed, whether they're applications or middleware or the operating system or any of the network components, we understand what that composability means on a larger sense of trusting that overall system and the capability that's providing. Next slide, please. You'll see a lot of references, by the way, to the ISO standards and in COSI. We're really in the update to 80160 now, we're very much focused on international standards because the commercial development today is worldwide. And we, as they talked about earlier, we want to have that kind of standardized framework, standardized way of doing business so we can ensure that everybody's reading off the same page. This slide I created after the SolarWinds breach because it really shows now how complicated this problem is. Within the organization, we have the business operations, our DevOps process now moving to DevSecOps with the integration of security, and then all of our supply chain partners. But the message I'd like to convey today is all of these things have to be built on a solid foundation of engineering, and systems security engineering is kind of underpinning that systems engineering process. Next slide, please. Well, I'm going to go very quickly. I included a lot of slides today because I know the slides will be made available to all the attendees. So some of these I'm going to kind of move by very quickly. I talked about the multidimensional protection strategy. This is the draft publication, and you can download a copy. The URL is on this slide, and I would very much encourage you, take a look at the publication, skim it, go into a deep dive if you think you can benefit from that. This publication is intended to be a resource. It's not intended to be a how-to document. We talk about literally 40 years of security design principles in one of our appendices. We talk about assurance, trustworthiness, but it's highly flexible. And it's tied back to the ISO standard 15288, which is a systems and software engineering standard. Now, there's a lot of processes in this document, but the good news is that you can pick and choose whatever you think is relevant to your lifecycle process to make sure that you pick the things that you need to make sure that whatever comes out of that pipeline is as secure as it needs to be. Next slide, please. When we talk about a system, this is just to show the complexity problem. The way we solve that is we decompose that system into system elements. And if you get into the 80160, you'll know that a system element can be anything from an application, it can be an operating system, it could be middleware, it could be a network device, it could be a person, it could be a process, a policy. All of these are considered system elements because they all come together to give that system a capability. Let's go to the next slide and I'll kind of expand on that. Ultimately, we're not just talking about your system. I think listening to the first two presentations, you get a very clear understanding that your system in that blue triangle there, that's what we call the system of interest. And that's all the things, all the elements that are composed to give you the capability for that system. But we don't operate in a vacuum. We are communicating constantly with their enabling systems, some within your enterprise, that are helping you carry out, your system carry out its mission responsibilities. There are also enabling systems that you depend on that are outside your environment of operation. That might be folks in the supply chain who you depend on for whatever things you need to make that system operate as it was intended. And then you have all the systems that you just interoperate with. And this is the kind of the picture of the world that we're operating in today. It's highly complex, highly interactive, and it has literally trillions of lines of code, billions of devices, and we have to try to reduce and manage that complexity so we really understand what's going on to the best of our ability. But there will always be uncertainty in the world of complexity. Next slide, please. One of the primary focal points of 80160 is the notion of an asset. We kind of have this view of cybersecurity that it's more of a compliance exercise where we're given a whole bunch of things to do on a list. And we try to get through that list and then we say, okay, now we're compliant. But I think all of us know that being compliant and being secure are not the same thing. So one of the notions of asset focus in a system is understanding what are your critical assets as opposed to all of your assets. being able to focus on the critical assets and then understanding what do you actually need to do to protect those assets. How much loss are you willing to sustain for the asset? Because there is no perfect security. There is no perfect trustworthiness. And so understanding what your risk tolerance is and how much loss you're willing to sustain, that is going to drive the level of protection in that system or that system element that you're designing and building. And without that notion, you can be going bankrupt on just trying to do too many things to everything at every moment of the day, and that's never gonna be successful. So the focus is on assets, and that's really kind of carries forward throughout the entire document. Next slide, please. Well, everything starts with the stakeholders at the top of the organization. They're the risk takers. They control the missions and the business operations, and they have a set of requirements that they need to put forth to make sure they have mission and business success. Now, some of those requirements then become protection requirements, protection needs, and those then are articulated into the systems level, and a subset of the system requirements end up being what we call system security requirements. And those requirements then are defined and implemented throughout the lifecycle process. This could apply to software, hardware, any component within a system, firmware. It all goes through the requirements engineering process. Now, in the world of Agile, that's going to happen a lot more quickly, and you're going to have feedback loops. But the concepts of verification and validation, which are two of our lifecycle processes, are very relevant no matter if you're using traditional development techniques or Agile development. Verification, did I build the module, the element correctly, or the system correctly? Validation, can I put steel on target? Did I build the right system? Is it effective in carrying out the mission and business needs that I hope to carry out? And this whole notion of requirements engineering is also very fundamental in the 800-160 publication. Next slide, please. This process of coming through the pipeline and producing software or systems is fundamentally a fairly simply defined process. We start with a problem, we come up with a set of solutions, and then we have to figure out, is the solution cost effective? And how much can I trust that solution? So this graphic comes out of the publication, and it kind of guides our overall thought process as we build systems and components throughout the life cycle. Next slide, please. There's been the whole notion of adequate security. It's kind of a continuum. We talk about security. Sometimes we have this pipe dream that we can have something called absolute security, and that's never going to happen in the world of complexity that we're dealing with today. And that's simply because there's a whole bunch of uncertainty in building software and systems. There's the limits of human certainty. And all these things, the constraints that we have in systems development or software development of cost, schedule, performance, and assumptions about what we're trying to do, all of that results in lots and lots of trade-offs as we're building software and systems. And so we have to understand that absolute notion that we'd like to achieve is never going to happen. So we have to look at something more practical. Next slide, please. We have a notion in the document we took from NASA. On this curve, you'll see below the curve, and the two axes are applying security measures and safeguards on the vertical axis, and then your cost, schedule, and technical performance issues on the horizontal axis. And all the solutions space below that line, those are a lot of different solutions you could potentially bring to the problem. But when you look at how much security I actually need, that's characterized by those 4 data points where A represents virtually no security and D represents going to the extreme level of security. There's a sweet spot along that curve, and that's where you do the fundamentals of the safeguards and countermeasures. All the things we do in blocking and tackling are down at the A level, and then we start moving up that curve and applying more and more security. At some point, we come to that sweet spot, and that's defined as that area that is as secure as reasonably practicable. In other words, we want to be able to have a system that we can trust, that can carry out the missions of business operations, but it's still got to be affordable, it's got to be implementable, and all of those practicality things come into play. So that's something we took from NASA. There's a lot of work in the world of safety that we brought into the 800-160 because, again, We want to try to model how they do things in the world of safety, reliability, survivability. Those are all things we can learn from in the world of cybersecurity. Next slide. Well, one of the exciting things, and we have a whole appendix on assurance, but we'd like to really probe this notion of an assurance case. How does a vendor make a claim, or a software developer make a claim about assurance, or what security functions they put into their product or their module, and what evidence can they bring to show that they've actually done that? The work they've done is actually done correctly and is effective. That's what comes out of an assurance case. It's bringing evidence forward that you can bring to consumers to help them understand how much they can trust your product, the module, as they put these things into the systems writ large. Next slide, please. When we talk about assurance, there are really three areas that we look at. There are certain capabilities that a system has and security capabilities, and we can apply a certain level of rigor as we build those different security functions. So the engineering of the actual security function becomes very important. Those design principles, least privilege, least functionality, complexity reduction. And then we have all the engineering tools and the methods that we use to build the system and the software. All of those things can be defined in what we call an assurance argument. It can be minimal assurance, it can be moderate level of assurance, or it can be very high levels of assurance with lots and lots of rigor applied. But whatever that level is, it's incumbent upon consumers to understand how much assurance has been put into these different components and how much can they trust them. Next slide, please. Well, we only have a little time left, so I'm just going to close on this slide. Again, comes out of the 800-160. These are the 14 technical lifecycle processes. And as we move into the DevSecOps world, we're going to be seeing how much of this work can be replicated in the DevSecOps world without limiting the speed, the innovation, and things that the DevOps world is bringing to the table. And I think there's going to be, it's an exciting time to explore these different questions. Ultimately, we want to get these products to be secure by design. So we don't have to add things. You can't add security at the end. It just doesn't work anymore. And I think this is going to be the method forward in the future that will really help us to get to the better place, to include all the things we're talking about with zero trust architectures today. Next slide, please. Well, this kind of brings us full circle. As I said before, the 800-160 Volume 1, once we get all the public comments back and we lock down that publication, again, pivoting to see how much of this work can apply to the world of DevSecOps. There's been a lot of tremendously great work by industry in the DevSecOps world. We want to understand what's been done, how it's been done. Is there a need to bring additional things into that security space, or are we doing things just about right? So again, we're going in with a totally open mind. And again, I think this is going to be the exciting work of 2022 and moving forward. Next slide, please. Well, that's my contact information. Again, I want to thank everyone for your patience today. It's been an exciting time at NIST. We're involved in so many projects that are on the cutting edge. And again, thanks for inviting me to be part of your day today. I hope you have a great rest of the day. I think we have time for a question or two. And if not, there's my contact information. Please feel free to send me email or call my cell phone. Whatever way works for you, I want to try to help you guys get to a better place. Thanks a lot, folks. Appreciate it.
Hey, Ron, it looks like we have a couple minutes. Get one or two questions in. The first one is, if you have zero trust infrastructure, how do you do trust zones in threat modeling?
Well, if you think about your house and you have a lock on your front door, the bad guys get through that initial level of protection. That's called your outer perimeter, your front door. Once they come into your house, all the valuables are in the different rooms of your house. Now, if you have a vault or a safe in every room of the house, those in essence are security domains. You can think of the zero trust architecture as collapsing that perimeter and putting those same safeguards and countermeasures, but on a smaller level of resources, a finer grain, if you will. And so those in essence can become trust zones. They're security domains. And I think that gets to the heart of architecture and engineering. That's really the thing that's different about what we're talking about today from the traditional way that we've done security for the last 30 or 40 years. And again, I think Kelsey covered a lot of the details of that and how you would actually do that. But again, I want to reinforce the point that just doing zero trust architecture and concepts, that's a subset of the overall trusted system design and development. It goes much beyond that. And you'll see in our Appendix E in 800-160, we have around 30 different design principles that can be applied throughout the architecture and in the engineering of the system to get to that certain capability. So again, I think there's a lot there for the future that we can rely on.
Well, let's try to squeeze in one more question. Doesn't the adequate security sweet spot shift with the evolution of attacker behavior and emergent vulnerabilities? Thinking Log4j, it seems that what is good. Yeah, it seems that what is good enough during engineering may well not be the same at some point in operation.
Right. That's the beauty of security engineering. You're never done. There's the life cycle process, then you're into operations, and you're on the point. You're looking for the next threat. The threats are coming at you 24/7. You have to be able to react to those threats. A lot of those threats we've seen before, the attacks. Some are going to be new. That's the whole notion of the zero-day attacks. So they hit you where you don't know you have a vulnerability. But the ability to monitor and react to those new threats and to be able to have the visibility into the architecture so you can go to the exact place where you got compromised and do something that's going to mitigate that vulnerability. That's the power of engineering. But if you don't have the visibility, you don't understand all the basic components, what levels of trust they have, how they interact, the composability issue. And that gets back to that one principle that I think is largely ignored called complexity reduction. We still want to simplify the infrastructure. Even if you do all the zero trust in the world, you can implement lots of zero trust and still have an overly complex infrastructure that is impossible to understand. And that's really what we have to work on. That's a harder thing sometimes to accomplish.
Excellent. Well, I think that's all we have for time for questions. Thank you for your presentation.
Thanks a lot, guys. Have a great day.
Thank you very much. Thank you, Ron.